Another metal known to the medieval scientists is bismuth. Here's a sample here of so-called hopper bismuth. It crystallizes in these beautiful crystals, like a hopper cart. And it has strange tinge color to it. In fact, you can identify bismuth because it has a pinkish tinge to it. I can show you a rod here of bismuth. You can see the crystalline bismuth inside, and you have to look at it very closely to see that it has a very faint pinkish cast to it. The entire metal does. Bismuth is known by the fact that it is a slightly pinkish metal. It is very heavy as well because it is at the bottom of the periodic table. Now, bismuth is very unusual because it is known as a diamagnetic material. What we've done here is we have a string here that we can suspend a sample of bismuth with, and if we apply a magnet to this, and you remember the magnet I showed before for iron, that is not strong enough. We have to use a much stronger magnet. Let me go get one. Neodymium iron boron magnet, the strongest permanent magnet material possible, even stronger than the samarium cobalt magnet, which is commonly known to people. If we put this magnet close here, you see it's actually pushing it around. You see that? It's actually pushing it around. It is diamagnetic, and when you release it, it comes back again. Bismuth is diamagnetic, the opposite of magnetic. You might actually find a beautiful example of bismuth such as this. Here is a bismuth egg. You see it's been put in a mold and allowed to crystallize, and it crystallizes in the beautiful hopper crystals that you see here. You find these in fancy shops. You see the pinkish cast again that bismuth takes on, identifying it as this particular metal. It's heavy too. It's heavy, almost as heavy as lead. Rarely you can find native bismuth. Here is an example of native bismuth here. Tiny, tiny crystals in phase, embedded in quartz. You'd be surprised at the number of native metals that sometimes can be found in nature. Bismuth here embedded in quartz.